Hi everyone, and welcome to this chapter of Dart Crash Course. In this chapter, we're going to talk about control flow. And control flow is any statement in any programming language that allows you to change the flow of your application, such as if and else statements. So let's have a look at those. The first thing that we do is to go ahead and create a project. So let's bring up terminal. And let's say Dart creates with a template of console, and we say control flow. Let's just call it that, okay? After it's done doing its work, we say code, control flow, and get rid of the terminal. And let's see in here, we go to workspace, our JSON, and we say zoom level. We've, up to this point, I think we've done 6, so let's just keep it at that. And to be honest with you, the only reason we're doing this type of zoomed window is simply because people who are watching the course on mobile devices, which are actually a lot of you, can also see the code. So you who's watching this course on a desktop, of course, this is going to be very big on your screen, but I think that is a good compromise to allow everyone to enjoy the course. So let's go into the bin folder and delete this file, and we create our example one Dart in here, the main function, the usual stuff. And then we say in the terminal, we're going to do fswatch, let's see, example1, just like that. And then we save our file and we can see the application has been run in the terminal, but we don't really have anything written yet. So as the first part of this example, let's have a look at if and else statements. And these are like the basic constructs for allowing the flow of the application to be changed based on some conditions. Okay, so an if statement usually looks for something that evaluates to a Boolean, a true or a false. So whether something is equal to something, or something is not equal to something, or something contains X amount of something else. So these are all conditions that evaluate to a value of true or a false. And that's what if statements usually do. Then we have else statements, which will take the application flow to a block of code should the if statement preceding them not having been able to evaluate to true. And then we have else if, which then take the control of the application to another block of code should the previous if or if else have not evaluated to true, and should this current else if evaluate to true. So it's just a lot of theory, but I think you all know what I'm talking about if you're already familiar with another programming language from before. So let's go ahead and create two constants in here. We say const your name, and we say it's equal to foo, and then my name, const my name is equal to bar, hopefully. Okay, I mean hopefully simply because I was hoping for a GitHub Copilot to complete that code, not that I hope my name to be bar. So let's go ahead and compare these two values. So we say your name, my name. So this is a comparison, okay? And we can say final foo, and you can now see this foo is evaluating to a value of Boolean, of type Boolean. So where this operator in here compares two values to the left and right, and then it says true if they're equal or false if they're not equal. So we say if your name is equal to my name, then we go into a block of code in here and we say print, we have the same name, okay? And then let's actually get rid of this else. So this if statement on its own is a control flow statement, because it's taking the application's flow from line 4 to line 6 only if these two are equal or if this condition is met, okay? However, you can also have else if. You can say else if your name is equal to foo, and then we say print hello foo. And of course, you can tail this statement also with even more else statements or else if statements. So let's say else if your name, let's see if GitHub Copilot can finish this. No, it couldn't. Your name is equal to foo, and my name is equal to bar, okay? And then we say print, I am foo and you are bar, like this. And then we can put an else statement and we say print something else. So looking at this code, you'll see that, well, your name and my name are not equal, of course, because foo and bar are not equal. So we're never going to get to this. And then we say, okay, Dart says actually, okay, the first if didn't work. So I'm going to go to the next statement. It's an else if. So I have to actually evaluate this condition. If it's true, I'm going to go to line number 8. Then it says, oh, is your name foo? then looks, yes, it is food, then it comes here. Now, the important thing to understand about if and else if statements or else statements is that as soon as one of these is evaluated, then this entire block is evaluated. So as soon as we fall into line number 8, then the next thing for Dart to do is to get out of this entire thing to go to line number 13 and a half. So you may be thinking that, but this condition is true, but this condition is also true because your name is Foo and my name is Bar. So why don't we come here after line number 8? And that's simply because the way just if and else statements work. As soon as you trap the code in here, then you jump out of this entire block to line 13 and a half, and that means the line between 13 and 14. Okay, so here, I mean, yeah, I think you understand. So it comes after line number 13. So even though two of your else if statements or else if statements might evaluate to true, it doesn't mean that both will be executed. Actually, the opposite. Only one, the first one that evaluates to true, will be executed. So if you run this application, you'll see that hello foo is being printed to the console and nothing else, simply because after this execution, Dart just jumps out of this entire code block. Okay, so just keep that in mind. Even though this condition is also true, simply because this one was evaluated first, it will be executed first and then jumps out. Okay, so that's something to keep in mind. That's for example 1. Let's create example 2, like here, and then we have our main function. Don't forget to change fs watch example 2, and we save our code, and then we can get rid of the terminal until we have our example up and running. Okay, now let's talk about let's talk about traditional for loops. They're very, very rarely used these days. I'm so actually happy for that because I never really liked traditional for loops. But in some languages, I mean, you're kind of forced to use them. For instance, if you're using C, but these days, not many people are using C. And even if you're using a system programming language such as Rust, that also has very little sometimes use for traditional for loops. You still have these modern for loops that we're going to talk about soon. But traditional for loops, they have 3 parts. One is the start of the loop, like where what you're setting as the start of your starting point of your variable or your loop is usually a value being assigned to a variable. But you can have some other funky stuff actually in your for loops that has nothing to do with assigning a value to a variable, but we are not going to talk about that. But in some C programs, you can actually see that people are kind of like using for loops for more than just a for loop, and it is quite funky. You can have a look at it on Google. But what we're going to do is to have a look at what a traditional for loop is and how we can use it in a Dart application. Sometimes you may have a good reason to use them actually, so let's not invalidate that reason. Let's say we have an array of names and we say it is foo, bar, and baz. In here we put the entire thing, okay, like this. And then if you want to go from the beginning of this array to its end and prints out every one of these items using a traditional for loop, then you can go ahead and say for, and then parentheses and your curly brackets. Then in here, you need 2 semicolons like this, and it is, you can see actually this is a valid code, and this is really funky, like but it is a valid code and it can be executed. All right, so we're not going to do that though. So let's go ahead and let me see if I can hide the status bar as well somehow. Status bar, good. So we can focus just purely on the code. Now in here, you can, the first part that we write is to create a variable that has an initial value. So we say a variable I equal to 0. You could have just gone and said int as well. That would have worked as well, but var is usually the typical thing that people write, okay? So we say, okay, the first thing that this for loop has to do is to create a variable called I as an index. It's very common to do that. I, j, k, all these things are usually common values to write, but you can go ahead and say index as well. That's fine. But we're going to use I. And this creates a variable called I, and as of type integer, you can move your mouse over it, you can see it's an integer, and its initial value is equal to 0. Then we go ahead and we say, okay, the next part of this for loop is where you want this I to actually stop the for loop. So what is the condition that stops the for loop? But usually that to me is actually a little bit confusing. So I prefer to think of for loops as, okay, I start at 0, and then I want to see like how do I increment these values? So I say I want to actually increment value of I by 1 every time. Okay, so I start with 0 and I increment I by 1 every time this loop is executed. And in here, then I think about, okay, but where do I want to stop? What is the stopping point? Well, as long as I is less than name's length. Okay, so the length of this guy is 4. So I will be first 0, then 1, 2, and 3. And then 3 is less than 4, but 4 is not less than 4. So this 4 will not be executed in here. So your I in the first round inside this for loop will be 0, then it will be 1, then it will be 2, then it will be 3. Then this condition is also not met, so Dart jumps out of this for loop. Okay, so basically we created a loop that goes from 0 to 3 inclusive, and then we can then access those members of the names array. And if we execute this application, you can see our values being printed. So foo, bar, bascox. Okay, so we can get rid of our terminal in here. So this is just a traditional for loop that starts with 0 and goes all the way to, but exclusive of the length of the names array. Now, you can also create loops that go backwards. So as I said, we start with a for loop with our curly brackets in here, and we print, let's say, names at I. We create a variable, we say var I, but this time around, we start at the end of this array. So we want index 0, 1, 2, 3. So if you take the length of this array, which is 4, and minus 1 that, then we get the index of the last item. Okay, so let's just go ahead and say var I. We start with names length minus 1. So that's 3. That's equal to 3, this statement in here, which starts at the last value. Then we say, okay, how do I want to increment or decrement I? Okay, I want to actually decrement it by 1 every time. And where do we stop? Well, we stop at I equal greater than or equal to 0. So how this looks like then is we start here. We say we start with the value of 4 minus 1 is 3. So I starts at 3 in here. Then it says, okay, then it looks at the condition. It says, is 3 greater than or equal to 0? Yes, it is. So go into the loop. It says, all right, I'll go into the loop. Then it says, okay, now it's 3. Then we get names at index 3, which is cox in here. We grab that value. Then the loop continues. Then this statement is not executed on the next loop. What is executed is the condition. It says, okay, first decrement I. Then it says, all right. Actually, to be honest with you, this will be decremented automatically for you, but let's just go with that. So let's say then it becomes 2, and then looks at the condition. Is 2 greater than or equal to 0? Yes, it is. It is greater than 0 for sure. So it comes into this loop. And then the same thing with 1. And then it gets to 0 and says, oh, is 0 greater than or equal to 0? Yes, it is equal to 0. So it executes the code. Next time around, I becomes minus 1. Then it says, is minus 1 greater than or equal to 0? No, it is not. So it just stops right there. So this loop will take I from 3 to 1 to 0 inclusive and exclusive of minus 1. All right, so that's what this loop does. So if you look at this, you can see next time around, this loop is printing the values inside our names array from the end, from the last item to and inclusive of the first item. Okay, so now you can also do some funky stuff with for loops in that you can, for instance, jump over elements, because in here you can see we've incremented this I by 1 every time or decremented I by 1 every time this loop is executed. But no one is forcing you to increment and decrement by 1. You can increment and decrement by 10 if you want to, as long as your array, of course, allows for that, for instance. But let's go ahead and create now a loop that starts at 0, but jumps over every other element. So we basically will print foo and baz. So foo, then we jump over bar, then baz, and jump over cox, and then the array is finished. Okay, so let's create something like that, and we can literally copy this code that we had here and paste it right there. Okay, and the only thing that we're going to change in here is saying instead of incrementing I by 1, just increment it by 2 every time. Okay, and we run our code, and you can see foo and baz are printed to the console. And you can actually print like some dividers between these pieces of code so that it is actually more explicit which one is which. You can see the third part is executed in here, which is just foo and bass. So just remember the third part of your for loops is basically you controlling how you increment or decrement, or how you affect your index variable, or the variable that your for loop is working with. Okay, and in here we're incremented by 2 every time, and in here we're just decrementing by 1, and here we're incrementing it by 1 as well. All right, so that was for our example 2. Let's create example 3 like this, and we create a main function, and of course fs watch as well. Example 3 just like that. Now we've talked about old kind of fashioned for loops, but there's also a new way of creating for loops, which is pretty much 99% of the times we're going to be using something like this. And even with the modern for loop, you can still get access to an index. I mean, I'm going to talk more about this, but what you need to know is that with modern loops, you usually lose access to the index. And sometimes, only sometimes, you still need an index, okay? But let's not get bogged down with that right now. Let me see if I can hide our terminal, and let's go ahead and bring our names in here again. I want just the names. Let's see if I don't want all of this. I just want the names, okay? Now, what we're going to create in here is a modern for loop that goes through these names, this names array. So in the previous example, if you go back to example 2, you saw that we created this type of loop. Let's bring it here, and then we write the equivalent of the same loop, but in a modern way, in a modern fashion. And the way to do that is you say for, exactly as we did before, and in here we say we create a variable, and it's a final variable because we're not changing it. Then we give it a name, and then we say in that array for final something in something. Okay, so this is an array, and we're saying for final, grab every name out of this array and then bring it here. You can see name is now a string variable available in this context. So then we can print name, and if we put a little divider between these statements like this, then you can see they're doing exactly the same work. So you can see they're printing the exact same output. So you could say that you really don't need this I. The only reason you needed this I inside this for loop was just so you could grab that particular element out of your array. But since we have already grabbed the name out of the array using the modern for loop, we don't need an index. So that's why a lot of people prefer modern for loops that don't work with arrays anymore. Okay, let's bring actually this little print statement back, because I think it is nice to divide or separate our output, so it's a little bit cleaner and more explicit what we're printing to the console. So in modern for loops, you also have access to some nice keywords, such as the continue keyword. So let me show you how the continue keyword actually works. So if you say for final name in names, and then we say print the name, all right, so this is pretty much doing the same thing as this one did. It goes through the array and then prints every item in there, okay? However, if we go before the print and we say, what we want to do in this case is to look at every one of these names, and if that name starts with the capital letter B, we want to not print that. So you've now learned about if statements. You could just say if name dot starts with the capital letter B, then we don't do anything. Otherwise, we print it. Okay, so let's have a look at this. You can now see it actually works fine. It says foo and cox are printed because bar and bass have B starting like as a starting letter, so they shouldn't be printed to the console. Well, that's a valid way of writing your code, but you could optimize this, because you see this block, this if statement, is not really doing anything. So it's just an empty statement. So you could say, I could flip this condition around. I could say if the name doesn't start with B, then I want to print. So we've now optimized this code a little bit more. So, and the output is the same. You can see it prints foo and cox in here, but it doesn't print bar and bass. However, there's another statement that you can use inside your for loops, and that is continue. And continue, what it does is it looks at your loop and it says, okay, I'm just going to jump out of the current execution of this for loop and give the for loop access and give the for loop a chance to get executed again. So if I write like this, if I say name starts with B, continue, and in here we say print name. So what happens in here, Dart says, okay, I'm going to go through the names. Let's go ahead in here and get rid of the terminal. It says, okay, the first element is foo. Then it gets here, it says, does it start with B? No, it doesn't. So it doesn't come here, and it prints foo. Then the next execution of this loop takes the value of bar, then comes here and says, oh, does bar start with a capital B? Yes, it does. Continue. That means don't go to line 13. Continue the loop. Jumps over to line 9, pretty much jumping over the bar value. Then name says, okay, I extracted bar in the previous loop. This time I'm gonna grab Baz. Says, all right, does Baz start with capital B? Yes, continue the loop. It doesn't mean continue to the next line. It means continue the loop, meaning that jump over the current execution of this loop. All right, goes here, grabs the next element. Is Cox in here? Does it start with B? No, it doesn't. So it doesn't come to line number 11 and prints that value to the console. Effectively just printing foo and Cox to the console. Okay, so that's what continue does. Now, you can also use break to exit loops. Okay, so let's go ahead and actually have a look at how break works. We've looked at continue, but there's also another keyword called break, which you can use in your modern for loop. So we say final, for final, name in names, and we say if, actually it guess it correctly exactly as not really exactly, but kind of like what I wanted to do. So let's say if name is equal to Baz, then we break. So you can imagine what this does. Break, if continuing continues the loop, breaks out of the loop entirely. So you can see the condition says if name is exactly equal to Baz, then what happens is says, is foo is equal to Baz? Nope. Then it doesn't come to line 20. It prints that name, so foo gets printed. Then bar is not equal to Baz, bar gets printed. Baz is equal to Baz, so it breaks out of this loop to line 23.5. Okay, so if we look at the result, foo and bar are printed, but as soon as we encounter Baz in the array, then we break out of the array. So that's what continue and break do. Break completely breaks out of the array, out of the loop, whereas continue continues to the next execution of that for loop if anything is remaining. Okay, because you can see in here, if we in here, for instance, said, if let's actually bring this down and create another example. I wasn't thinking about creating this example, and we're going to delete it, but I just wanted to demonstrate something in here. Let's say that we put another break here, prints with like a little separator, and you see the last item is Cox in here. So let's just go ahead and say if name is exactly equal to Cox, then continue. So you may be thinking, oh, but continue will just go to the next statement. So the next for loop execution, is that going to crash the application because there is no value after Cox in the array? Well, it doesn't, because modern for loops are actually intelligent. So it encounters Cox, it just doesn't go to line 31, continues the for loop, and for loop already knows that Cox was the last value in the names array, so it breaks out of this for loop. Okay, so just keep that in mind. Continue doesn't necessarily mean force continue. It just means, well, just go to the next element if there is any, or break out of the for loop if there isn't. Okay, so keep that in mind, please. Now with traditional for loops, which we had a look at, we could also go backwards in an array. But in here, the only examples we're seeing is going forwards. So how do we go backwards in an array? Well, there are some utilities that allow you to do that. So if you say for final name in names, what you can do in here is, if you want to go backwards, is use the reversed property, reversed. So it's a property that gives you an iterable. We haven't really talked about iterables yet. We actually have a chapter dedicated to collections and of course iterables as well. But just for now, know that it's kind of like an array, kind of. All right, or a list as Dart calls it, but it's a little bit more advanced than that. But let's not get bogged down with that. Just know that if you want to go and reverse an array or an iterable, then you can use this reversed property and go backwards. Okay, and we can print these guys. Let's say print name, and then we can have a little separator in here Good. And let's have a look at the results. You can see we're going back cox, baz, bar, and foo in here. Okay. So that mystery is also solved. Now, we are going to talk more about iterable soon, but I just want to show you an example in here. So with usual for loops, we saw that, let's say we say for var I is 0, and then we say I is less than 10 and I plus plus. So we say go from 0 to 9 inclusive. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But stop at 10. So don't do the 10 because 10 is not less than 10. All right. So if we print the I value in here, you can see we pretty much created a counter. So it goes from 0 to 9 inclusive. How do we do that with modern for loops? If we can't control the variable, how do we create a variable that goes from 0 to some value? Well, the answer to that, simply because Dart doesn't have support for ranges. Like in Swift, you could say 0 to less than something. And in Rust, you could do the same thing, like this. Okay, but Dart doesn't have support for ranges, unfortunately. Even Python has support for ranges, but Dart doesn't. And this is one of the things that sometimes makes me a little bit disappointed, because Dart is supposed to be a modern programming language, but it lacks a lot of modern abilities that other languages have. And hopefully these are going to be added. The more the community asks for these things, I'm doing my part on Twitter and LinkedIn, raising these issues, but I think more people need to talk about the fact that Dart really isn't on par with most modern languages, such as TypeScript, for instance, and JavaScript, even for that matter. So if Dart wants to compete with these languages, it really needs to add some of these basic functionalities. And some of these are coming to the language, but I just wish they could come a little bit faster. Okay, enough about the rant. Let's just go ahead and say we want to create like a range. How do we do that? We say for final value in, then we create an iterable, and then we call its generate function, and we say 20. Give us 20 values. All right. And if you print them to the console, you can see now we got 0 to 19 inclusive, because 0 to 19, there are 20 values in this range because 0 is the first value. So if it was 1 to 19, it would be 19 values, but since it's 0 to 19, there are 20 values. So the value that you provide to the generate function is it's exclusive. So 20 is not included in the list. It's actually excluded from the list. Okay, so this is how you would create that type of array, or how do I say it? This is how you would create that type of range if what you're interested in your for loop is actually that index. So here the value, perhaps we could in here say this is an integer. So so let's see if the result is correct as well. Yes. So you can see it. This is if what you're interested in is the index or that integer, then you can create it like this with modern for loops as well. Okay. So that was enough with example 3. Let's go ahead and create example 4. Dart in here, our main function, and of course let's not forget fswatch. Okay, and then we can save our file and get rid of our terminal and start working with example 4. Now the other type of loops that you can create in Dart and most other programming languages is called a while loop. And it is a little bit difficult to explain it, like just explaining it theoretically, but I just want to show you how it works so I can explain more using examples. So let's bring our names array in here, or maybe this is actually pretty nice instead of foo, bar, and baz perhaps. Okay, so this is cool too. Let's just leave it like that. Now let's go in here and create a while loop. All right, so while loops, they have a condition in the beginning. So it's a loop that evaluates just a condition. All right, that's all it does really. And then if that condition is met, then the loop is executed. Then the next time it comes back to the condition, says, is the condition still true? Yes, then the loop will be executed. Otherwise, it jumps out the loop. So it's while loop is a loop that has a condition in its beginning and executes the body of the loop if that condition is met. That's really all a while loop does. Okay, so let's create a counter, and we say we have a counter equal to 0, and then we say as long as. So usually the way I read while is as long as. I say as long as. Okay, so if in my head I say as long as counter is less than the length of names. And then what Dart does, it says, okay, the condition is counter should be less than the length. So it says 0 should be less than 4. Is it? Then it says, yeah, it is actually. So then you can say print, for instance, names counter. Okay. So let's bring these back. We say counter is less than names length. But what happens in here? So let's see what Dart does when it gets here. It says, okay, is the counter less than 4? Yes, it is. Print the name at that index, so John. Then it goes to the while again. Is counter still less than 4? Yeah, it is still 0. So basically what we created in here is like a loop that never ends. So if you run your application, you can see just John being printed to the console. It just never stops. You see, so we created like an endless loop, and that's not what we want. So let's bring up example 4 again as fswatch and not save our file, because otherwise we go into the endless loop again. So what we want in here is somehow to affect this condition that we've created in here. And the way to do that is to increment our counter every time that the while loop is executed. So one way of doing that is going to the next line and say counter plus plus. This is something that a lot of people do. They increment their counter at the end, for instance, of their while loops. And if you then look at the output, you get John, Paul, George, and Ringo printed to the console as you'd expect. Now, some other people may go ahead and say, I will increment my counter in here, because we've already learned about this postfix operator. What it does, it returns first the counter and then increments it. And that's the reason it is placed after. But if it was placed here, it will increment first and then it will return the value. Okay, so let's actually have a look at the result of this. So if you say plus plus after, what happens is counter is first equal to 0. Names at the index of 0 is printed to the console, John, and then counter is incremented to the value of 1. The next time while says, is 1 less than 4? Yes, it is. Grab names at the index of 1, which is Paul. That's why Paul's printed here. Then it says, okay, then increment counter after the print statement is done, or after this name has been placed in this subscript. Then it will be 0, 1, 2, 3. And then next time while says, is 3, after 3 is incremented to 4, then it says, is 4 less than names length? No, because 4 is not less than 4, then it jumps out of this while statement. Okay, so some people prefer to do it like this as well. Now, some other people may actually decide to do things a little bit differently. So they could say if counter plus plus, a while counter plus plus, what does that even mean? So does that mean that we can get rid of this? If you run your application now, you will see that you'll get an exception in here. Let's have a look. It says Ranger. What happened in here? Because you can see in here, let's go ahead and look at the output. You can see the first value was Paul, but why? So what happened is that counter started with 0. Then Dart came in here and said, is this being assigned to something? No, it's not. So there's nothing like a final blah is equal to that before it. So it's not being assigned to anything. So it increments it immediately. It says, okay, then I should be 1. All right. So that's why it completely jumped out of John, because the first iteration of this while loop counter was incremented from 0 to 1. It says, okay, is 1 less than names length? Yes. All right. So what is really happening is, to be honest with you, we need to have a look at the last iteration of this while to completely understand what is happening. And that's when we get to Ringo, which is here. What is happening is that this is really incrementing our counter right after its comparison with the name's length. So it says, okay, is counter less than name's length, which at this point is 3. Then it says, yes, it is. Then it increments the counter to 4. And then we come to the while statement, and there is no name at the index of 4 because indexes are 0, 1, 2, and 3. So you should really avoid doing code like this to increment or decrement your counter. For instance, in the while statement itself, you should instead try to have a very clear point inside the block of the while statement, using which you increment or decrement or somehow affect your condition. And I mean, I've worked with a lot of enterprise applications, and usually people prefer to have a separate line in which they affect their while statement. And it's usually written like this. The next level after that would be to do it like this, but I've seen a lot of people shy away from doing this simply because it's a little bit more cryptic. You have to actually go and look at this print statement, which shouldn't really have any side effects. If you write your code like this, you're having a side effect, which pretty much means that your print statement is not just doing printing, but it's also affecting a variable. And we shouldn't do that usually, okay? So it's kind of like frowned upon. So if you go back to our FS watch, we can run the application and you can see this way, our code runs okay. And this way it could also work. But so I'm just going to leave both of these examples in here so you can have a look and decide which one you prefer to use, okay? Now, as I mentioned, you can increment the counter in different ways. Some ways are better than others. Like in my opinion, this is the best way of doing it. After that, this is the best way of doing it. But one of the worst ways of doing it is to increment. Let's actually print our divider in here, is to doing mental gymnastics for incrementing the counter. So you could say counter, we start with -1, and then we say while plus counter. Plus counter is less than names length, and then we print the names at that index. So what happens in here is we start with -1, and then we increment counter, and then we compare it with names length. So we start with -1, then it becomes 0. Is 0 less than names length? Yes. So names at index 0. Next time, increment 0 to 1. 1 is less than 4. Yes, blah, blah. So this statement is pretty much doing the same thing as this, but it's, to me at least, is a lot more cryptic. We're starting with -1, and we're really not gaining anything. The only thing we're gaining is just that we're getting rid of this kind of statement and this kind of statement. And the while loop is controlling its own variable. So you could say that the benefit of writing code like this is that the while loop is in itself in control of its counter variable. But other than that, we're just making the code look a little bit more cryptic. Okay, and you can see the output is exactly the same as before. So we're getting John, Paul, George, and Ringo printed to the console. So I just want to show you another example of incrementing or kind of affecting your index variable inside a while loop. Okay. And of course, you can also go in reverse order, because the only thing you're doing in here is evaluating a condition, and also, of course, incrementing or decrementing a variable. You can also go in reverse order. So let's have a look at how we can do that. If we say counter starts with the length, names length, so we start with 4, then what we could do is to say while we subtract 1 from a counter, it should be greater than or equal to 0. And then we print names at that index. So let's see what happens in here. We start with 4, okay? Then we come in here and we say, okay, take 1 away or subtract 1 from 4. So 3, is 3 greater than or equal to 0? Yes, then print Ringo, which is at index 3. Then it goes to the next while loop, says, okay, take away 1 from 3, so it's 2. Next time it's 1. Next time is 0. 0 is still greater than or equal to 0. So we get John printed to the console. Next time around, we will be at -1, and -1 is not greater than or equal to 0. So the while loop stops executing its code. So the result is that we're going in reverse order. You can see Ringo, George, Paul, and John being printed to the console. So you can also do that with a while loop, okay? Now, we've seen while loops now, and you can see that while loops are executing their condition at the beginning. But what if we don't want to execute the condition at the beginning and instead want to execute it at the end? So let's see an example. Let's see that we say counter is actually equal to 0 now. And then we say use the do statement in here. So what do does is, is that it executes its code first and then looks at the condition. So you're just pretty much creating a while statement, but the while is at the end. Then we say do that while the counter is less than, oops, I can't spell counter, is less than names length. Okay, and then we print our, we say print names counter plus plus. So what happens in here says, okay, counter is 0. Then Dart looks at the do statement, says, okay, I'm not looking at any conditions. Just execute this code immediately. Then it says, okay, prints the names at this index and then increment the index or the counter. So prints names at index 0. Okay. Then it says before finishing with line 27, counter should be 1. Says, all right, counter is now 1. Then it comes to the while statement. Is counter less than 4? Yes. Then comes in here. Okay. Print names at index 1 this time, which is Paul. All right, I'll print Paul and then increment counter to 2. And is counter less than 4? Yes. So I think you get the point. So it's pretty much just like our while statement. But what it does is that the condition is evaluated at the end of this block. Okay. Now, we've looked at these, but let's actually mix these with break and continue as well. So we've seen how break can break out of a loop, and we're now gonna mix it with our do statements. So let's grab this guy in here and actually with the print statement before it, like this, and bring it here. And what we're gonna do is to say, okay, we're printing these names. So Paul, what was it? John, Paul, George, and Ringo. And what we're going to do right after this statement is to say if our counter is 2, then break. So what happens is we start with 0. So John is 0. Paul is 1. George is 2. So then we come into this if statement because the counter is 2, and then we break out of this entire do. So at the last in this last statement in here with the do while loop, we're only printing John and Paul, because as soon as index hits the value of 2, we're breaking out of this do statement. So let's see the results. You can see John and Paul printed to the console, but as soon as we get to George at index of 2, we're breaking out. All right. So you can not only that, but we can also have continue as well. So let's grab this code in here. Okay. And maybe the print statement as well. And then we say, okay, counter is 0. And we're doing the exact same thing like before. Let's say final name is names at counter plus plus. So we start with 0, grab the name at index 0, they increment the counter to 1. And then we say if name is equal to George, like this, George. All right. Then we say continue. And then in here, we say print name. All right. So what happens in this case, you'll see now, is John, Paul, and Ringo are printed, but George isn't, because we're saying continue, just continue to the next round of this do loop. All right, this is pretty much like we've seen before. And you can also have an else statement in here. Some people prefer to have if and else, just for the sake of it, but you don't have to. I mean, the output is exactly the same, simply because this continue will just jump out of this if statement and continue with the loop. So you don't have to have an else because the effect is pretty much the same. So you could have a little bit simpler code without writing the else, I would say. Okay, so that was it really about while and do. So while evaluates its condition first, whereas do evaluates its condition last, after basically its first or initial. Actually, no, I can't say that. Do executes its condition after its body has been executed. Its block of code has been executed, which is inside the curly brackets. Okay. So enough with example 4. Let's go create example 5 in here and fs watch it. Of course, main function maybe before. And we say fs watch example 5 in here. Okay. Good. And save this file. We can get rid of the terminal for now. Now, we've already looked at switch before, but let's have a look at switch one more time. Let's go ahead and create a little generic function in here, because switches are also contributing to control flows, and that's why we're talking about them right now. Let's create a function, and we say describe, and we say a generic value, and we say our value is here. So what we're going to do in here is to take any value of any data type and try to explain what it is. So we say switch that data type, and in a switch statement, you can see we can have various cases. It is a little bit strange to me that this code is actually valid Dart code. It's like an empty switch. but what's the point of it? Some other languages will stop you right here and say, well, your switch isn't doing anything in here. Okay, but the way to write a switch and this control flow statement is to have cases. So you say case something and colon in here, and then you'd break, then you case something else, okay, and then you have a break. And in here, between your cases and your breaks, you will do something basically. So in here, you have to, your cases need to kind of match what your switch is doing. So here we're switching on a generic data type. In here, we need to write data types. If we were switching on an integer, then we would have to write values that are conforming to an integer. But since we're switching on a data type, then we have to write data types. And we say in here, if it's an integer, print, this is an integer, okay? And then you'd have to have break statements in Dart because you can see, otherwise we will just fall through to the next line, okay? Like this, and Swift has support for fall through. So let's break in here. And then the next line we say case double, and we say this is a double, all right? And then we can say strings, bools, etc. So string, this is a string, and let's do bool, case bool. And let's see if GitHub Copilot can help with that. Then we can also say case a map of string and string like this. And then we'll say this is a map. And then there is a special case inside switch statements, and it's called default, which is indeed how you would do it also in, for instance, Swift. It's just called default. It's not called case default, but it's just called default. And here we say this is something else. All right. So it is very important when you're creating switch statements that your switch statements are inclusive of all the cases that could possibly happen. So in this case, if we missed out on writing this default, even though Dart doesn't say anything, but we've pretty much created a switch statement that is not inclusive of all its cases. So what if I pass, for instance, a list of strings to this describe function? Well, it's not an integer, it's not double, string, bool, or map, so nothing will happen. So this switch statement is not inclusive of all possible cases for what it is basically switching on. And previously, in like many years ago, I would say before 2014, when Swift came out, this was kind of a thing. A lot of people could write switch statements, but when Swift came out, and also in Rust, you should never write switch statements like this. Your switch statements should always cover all possible cases. That means if you haven't covered all the cases, you should have a default case, okay? Like this. And we say print, this is something else, and then we break like this. So let's test this out. We go ahead. I actually have prepared some examples so I don't have to type them myself. So let's go in here and we say, describe the value of 1, which is an integer. This is a double. This is a string. This is a boolean, and this is a map of string and string. And of course, we can give it a list as well. Let's just give it a list of 1, 2, and 3, and 4, and then see the results. So you can see the first one is, I'm not sure why John is printed in here. It's from the previous example. Let's just run this again. The first one is an integer. Next value is a double. Then we have a string. Then we have a boolean, as you can see in here. Then we have a map of string and string. And then we have something else, because this was not covered by our switch. So we're falling into the default case. Okay, so that was quickly a little lecture about switch. Let's close this guy, and then we go and say example 6 Dart. Okay, a main function. Stop this execution, and we say example 6, save, and get rid of our terminal for now. Now, for loops, you can also execute them over maps. However, since the records or tuple feature of the Dart programming language is not ready yet, it's in the works. A lot of developers have asked for it for a long time. And again, this is a feature that is available in pretty much every other language already. It's available in JavaScript, TypeScript, Swift, Rust, Python, you name it. There are tuples. However, Dart doesn't have it. And this is one of the reasons I think Dart can sometimes be falling behind other modern programming languages. So I could really wish for these features to be available a little bit faster so that Dart can compete with other languages. And some people may argue, well, it doesn't have to have those features, but I would argue that if 99.9% of all modern languages that Dart is competing with have these features, then Dart has to have those features. Otherwise, you can say that it is falling behind. It is the same thing with everything else in life. If you're competing with others and you don't have the same qualities, then you could be falling behind. If Dart wasn't competing, for instance, with JavaScript, then you could say, well, it shouldn't care. But one of Dart's main goals is actually compete with JavaScript. So let's now have a look at doing a modern for loop over maps. And a map is pretty much like a dictionary of keys and values. So I've created a map in here. Let me just paste it so we don't have to type it by hand. So you can see it's a map. Keys are strings and values are dynamic. So I think actually it's an object, okay? Because here's the value is a string, here's an integer, here's a double, here's a boolean, and here's the value is actually its own map of string, okay? So this then is a map of string and object. So how do we iterate over this info and get all its keys and values and print them to the console? So you could say for final blah in info, okay? And as soon as you do this, actually let's call it entries maybe, you can see this error. And it tells you that you can't for loop over this simply because it is not really iterable, okay? It doesn't implement iterable. And so the reason behind this, I mean, this would work in any other language, but Dart doesn't have this feature of records or tuples yet. So what you have to do is to say you're iterating over the entries of this guy. And then your entries variable, or entry, let's call it, will now be, you can see, is a map entry, which is its own class. Then you can say print. Let's see if Copilot can complete this. And you can see every entry has a property called key and another property called value. So if you execute our code, you can see, let's see here. Yes, name is printed with as a value of John. Then age is printed with a value of 30, height, blah, blah. And address also has its value, which is its own map basically in here. So it's a little bit awkward, but it is what it is in Dart until we have records. So if you want to iterate over or loop over all the entries inside a map, then you will have to access the entries property of that map, and then you will get the keys and values. As you can see in here, a map entry has a key and a value. All right. So that was example 6. Let's go ahead and create example 7 in here. And then we say a main function. You already know this by now. And then we go to our FS watch, of course. And then we say example 7 in here. All right. Good. So in example 7, we're gonna switch on integer values. Now, this is something that we've already done, but I just wanted to write a little bit more like complete example. And in this example, actually, we can't have FS watch, unfortunately, because FS watch is gonna interfere with standard input. So let's go to our terminal and stop FS watch like that. And what we're gonna do in this example is ask the user for their age, okay? And if they say that they're 10 years old, we're gonna say you're 10 years old, great. If they say they're 20, we're going to say, well, you're 20 years old, still very young. If they say 30, we say you're 30 years old, you're an adult. And then any other age, we say you're age years old. Or if they say like 50, we say you're 50 years old. So that's the goal of this example, switching on integers. Okay, so our example is going to include Dart.io. So let's go ahead and import that. We say import Dart.io so that we can use with, you can basically use std in and std out. So let's create a loop in here, okay? And this loop, what it is going to do is simply it is creating an endless loop. So we say do while true. So it's an endless loop, all right? And you'd say, well, how do I get out of this? Don't worry, we're going to talk about that soon as well. So the first thing that we're going to do in this loop is just to tell the user to enter their age or type the word exit. Okay, and then we're going to handle this exit in a special case. So if the user actually types exit, then we're going to exit this loop. And you already know how to exit loops like this using a break, right? If I can spell it. So let's go ahead and first say std out dot write ln. Actually, maybe write, because we want them to write the age right after we type we output the command. So we say enter your age or type exit. like this. Okay, so if we run this application now, and we'll go to our console in here, and we say dart bin.example7.dart, you can see, oh my god, okay, so it didn't really stop in here because we're not actually asking the user for an input. Let's just ask the user for an input. So we say final input is stdin.readLineSync, I believe the function is called. All right, and then we say print input, and then run our application. You see now that if we run our application, then this is printed to the console, and then we could just say hello, and then it prints hello, or we could say one, prints one or two, whatever. So it never ends. Let's just handle the case where the user actually prints exit. Okay, so, or sorry, inputs exit. So I'm gonna stop the terminal in here, and we say if input is a exit, then we break out of this loop. Okay, then we also have to handle a case where the input is null. All right, because you can see this is an optional string. Because if we execute our application, I could just print I could just type enter in here. Okay, and then you can see just nothing happens in here. So we say else if input is null, then we say then we could say stdout.writeLn. We say invalid age, try again, like this. Okay, and then we continue the loop. So we don't basically continue the code after line 12 and a half. So let's run our application one more time. You can see it says enter your age or type exit. Now let's see. Then if I press enter, then we're falling into this case. The value is null. So then we get, oops, let's see, if input is exit, and then we run our application. And then if I just say enter, I can see that nothing is really printed in here, and simply because probably input is actually, it is an empty string. So what we could say if input dot length or 0 is equal to 0, something like this. Let's see, conditions must have a static type of bool. Could it be that we need to put it in parentheses like this? Yes, and let's save that and run our application again, and then press enter. Now you can see invalid age or try again is printed to the console. Okay, that's really good. So we got that working, and if we print exit, then the entire application exits. So our statements in here are taking care of two edge cases. One, the exit statement, and the other one is that input being empty. Okay, so that's really good. Then what we need to do after this is, since we've taken care of the edge cases, then we can assume that the user has entered something at least remotely similar to what we asked them. Don't forget that the user can always go in here and say blah, blah. And this is not an integer, so we have to handle that somehow. Okay, so let's go ahead and try to parse this input as an integer. And this is what GitHub Copilot is suggesting me, and this is exactly what I wanted to do. All right, so input, I mean, it would have been really good if we didn't have to do this in here, okay, like this. And what I think the reason behind this is that we could have an or in here and say input is equal to null, and then we wouldn't have to do this. Okay, so in here we're saying if the input's length is 0 or that the input is completely null, then go here and continue the loop, so don't come here. And Dart's static analyzer understands that if we are here, then input is not null. Because if input was null, then we would have fallen in here and continued the loop to the next loop. We would have never ended up in line number 14. So that's a trick to get rid of that little exclamation mark that we had there to force unwrap the input. Then what we could say, because try parse will of course try to parse this input as an integer, and if it can't, it will return an optional integer to us, which is equal to null. So we say if age is equal to null, then we say stdout.writeLn invalid age, try again, like this. Okay, and then we will continue the loop. Okay, so this is taking care of the edge case where the user doesn't really understand what we're asking them, so they enter some string instead of an integer. Then we will switch the age. So we say we switch the age, as you can see in here, because here age is guaranteed to be an integer, even though it's saying optional integer, but it is guaranteed to be a real integer in here. Okay, then we say in case that age is 10, then we say you're 10 years old. Great. And then a break. Then we say if you're 20, then you're 20 years old, still very young, as I mentioned at the beginning of this example. In the case you're 30, you say you're 30 years old, you're an adult. And in any other case, we say you're age years old. Okay, so if they say 50, we say you're 50 years old. And that is it really. So I will then save this file, and let's go ahead into the terminal, bring it up so we see it in its entirety. So let's go ahead in here and say 10, you're 10 years old, 20, 30, oops. You see, now this was not a valid integer, so the try parse didn't get a valid integer in here. So let's go ahead and have a look at the code. Try parse actually returned null in here, in which case we said invalid age. You can see it right here. Now let's say 50, which is not one of the cases that we've supported. It just says you're 50 years old, or 60, and we can also type exit to exit the program. Okay, so this was just a little application that we wrote to demonstrate how you can use switch, and of course, standard input and output. So we're done with example 7. We can close it and go ahead and create example 8 in here like this. Okay. And of course the main function, and perhaps I wonder if we should do fswatch for this, but maybe not. I don't think we have to actually do fswatch. So this example is going to be very similar to the previous example. So what we could do is to go to example 7 and kind of like copy it and bring it to our application in example 8. Okay. And instead of saying enter your age, we're going to say enter your name. Enter your name like this. And then we take the input and we pretty much do the same thing as we did before. So we say if input is exit, then break. If input length is 0 or input blah blah, and then we say invalid name, try again, and we continue. Okay. And then since our input is a string and we're actually asking for a string, then we don't need the age basically. So we get rid of that. We get rid of that because we're not working with age anymore. We're actually working with this input, which is our name. Then what we can do is to say switch on the input, and we say to lowercase. So what happened in here is that we're switching on a string. So this is not like you switching on an integer where you have cases of integer. So if you're switching on a string, your cases should also evaluate to strings. So in this case, we say if the lowercase of the input value is John, let's say John, okay, then let's just say actually we're gonna have some funky stuff in here. So let's get rid of that. So we have John, and then let's say Jane, okay, and in here we say hello dollar input, you have a great name. Okay, now what we want to do is to learn how we can go from this case to this case. So in case the name of the person is John or Jane, then we want to print this statement. So you could just remove that from here and have case John and Jane both execute this code. Okay, and in any other case, we will have a default, and we say let's remove this. We say hello.input. Okay, so only in the case of John and Jane, we're saying you have a great name, just for demonstration purposes. Okay, so let's go to example 8 and execute it like this. Then we say example 8. All right. If the user says exit, then we exit the program. But if they say, for instance, Vandit, it just says hello Vandit. Or if you say Andrew, says hello Andrew. But if you say John, even if you type it uppercase, it still says hello John, you have a great name. Or Jane, hello Jane, you have a great name. Okay, so it doesn't matter how you type it, simply because we're basically converting it to lowercase and then comparing that lowercase value to John and Jane. It doesn't matter how you type John. It could be John like this. Okay, it still goes here. So this example shows you how you can fall through in Dart from a case to another case. So the case John is executing the same code as Jane and vice versa. However, there's another way of doing this, and that is simply by jumping to labels. Dart surprisingly supports labels in its switch statements. So you can go ahead and give this guy or this girl a label, and you could call it to Jane. So it has its own label. And in the case of John, you could say continue to Jane. Continue to Jane, like this. I have to say I've looked at Dart code for a very long time. I've been working with Dart and Flutter for a very long time. I've seen this example once, and including this example I'm writing here is the second time I'm working with this. So usually this doesn't happen, but in some very complicated switch statements, this might happen, and that's the case I've seen in an open source project. So just know that, and I just wanted to bring it up, that Dart supports this kind of statement, that you can jump into from one case, you can jump into another case using a continue and a label. So you just need to know that it exists. But if you want to use it, then you really have to have a good reason, because this is equal to this. So why would you want to write so much code if it's achieving the exact same thing in here? And in some other languages like Swift, you need to make code like this more specific. Like if a programmer looks at this, they could be thinking, oh, did they forget to write something for John, or is this intentional? And that's why Swift makes it very explicit that you have to say fall through. So if you do this in Swift, then you are not only helping the compiler, but you're also helping your coworkers understand that you intentionally want the John case to fall through to the Jane case. Okay, but in Dart, you don't have to do that, which makes it a little bit less explicit, but also understandable still. Okay, that was it really for this chapter. Let's go ahead and commit our code. So let's say git status and git add, and we say git commit. Let's actually see the status, because I think it's only this folder. Yes, it is. And we say git commit, and we say control flow, like that, and then we can also push our changes to the remotes. Okay, so hopefully you enjoyed this chapter, and I hope to see you in the next one.